Welcome back. We're going to begin our studies of Unit 8, where we'll talk about annuities and sinking funds. And I'm going to head right into a PowerPoint and share it with you. All right, you can see on the front screen content coming from Chapter 20 as it relates to your textbook. The PowerPoint will consider some examples, some formulas, a lot for us to look at in this section. So let's get rocking. All right, when we worked in or I should say in Unit 7, we talked about what would happen if you just make a single investment and let it ride in terms of compounding, and it was a one-shot invest deal. In the actual purposes of investment, most of us don't do that. Most of us make a series of investments, maybe once a week or once a month as the time goes out. And in that context, we're looking at what we're going to look at in this unit, the idea of an annuity, a concurrent, a section of regular payments, often the same amount. And then we're going to ask ourselves, how much will that grow into in the future? Or we might decide that, in 20 years, I want to retire and I want to move to Arizona. And when I get to there, I want to be able to take $50,000 out a year to live on. How much would I have to put in the bank or into an investment opportunity right now so that at the end of a fixed amount of time, I could head out to Arizona and just catch some sun? So we'll look at that as we go. We'll look at two different kinds of annuities. We'll look at ordinary annuities and annuities due. And we'll wrap up the unit with the notion of sinking funds, and we'll take a look at how that plays in terms of what we've got. The formulas in this unit are a bit cumbersome. And again, as before, I'm not going to rely on a table. We're going to grab a calculator and hold on for dear life. Excel certainly is a viable tool for us, and we'll probably make some use of that as we play. Units got objectives for you. There's 20.1, there's 22 and 23. There'll be a list later in terms of the folder that contains everything for the unit. You can find them there detailed as well, or you can read them in the PowerPoint. You already know that I just get annoyed having to read things to you. So I don't know about you, but that's always been my read as a student. Here are some basic definitions for us as we begin. We'll look at annuity as a steady series of payments that are going to accrue to a fixed value. The term of the annuity is how long from the beginning until you've got that last payment, and then you can take a look at what it's worth. The future value is what it's worth at some point in the future. The present value of an annuity means how much is it worth right now, so that maybe I could draw something from it for every year for 20 years and live in Arizona, Um, some words from yours truly. Again, no tables for Dell. It's calculators or Excel, and I just think that's the way for us to run. Don't get intimidated by the formulas. They're not pretty. Grouping, as we saw previously, is pretty key. So we want to make sure that we group the entire numerator. Sometimes we'll have to group the entire denominator. You don't want to round until the bitter end. All right. In mathematics, we round at the end answer, not in subsequent steps along the way to get to the end answer. Section 20.1, here we go. We're going to talk about an ordinary annuity and an annuity due, and we'll find out how much they're worth in the future. And the difference between these two, you'll see shortly, has to do with when the investment is made in terms of where interest is earned. Okay. Future value means what's it worth some point in the future. The term of the annuity is what's the time period from beginning until the end. Your author gets into this contingent annuities and annuities certain basically is there a known end or is there not a known end? And in terms of his examples, I don't know. I found these a little wanting. I understand that a life insurance would be a contingent annuity because quite frankly, after you die, they're not paying more. An annuity certain his example of a mortgage, while I understand, it has a fixed end. I never quite interpreted a mortgage as an annuity, but I guess we could. All right, ordinary annuities, regular deposits are made at the end of the period. So at the end of whatever the period is, might be a quarter, might be a month, it might be a year, but your deposits are made at the end of a particular period. And annuities due, your deposits are made at the beginning of the period. Okay. We're going to do one by hand. We're going to do brute force. And then we'll take a look at one that has the formulas and it will make us appreciate the formulas a bit more. It's not hard, but again, as we saw previous units, if it's a long span of time, it's going to be a major tedious process. Okay, so let's take a look. Here we go. We are talking about ordinary annuity. And on an ordinary annuity, the thing to remember is your deposit is made at the end of a period. So Bill's got an ordinary annuity. He's going to run it for 3 years. Okay, he's going to feature a $4,000 payment each year, and it's going to earn interest at a rate of 8% compounded annually. And the question for us is how much is his annuity due at the end of that 3 year span? All right, so at the end of year one, he makes his first payment. It's $4,000. Notice that no interest is earned for year one because the payment wasn't made until the end of year one. So at the end of year one, his balance is $4,000. His annuity is worth $4,000. Okay, end of year one, worth $4,000. Let's move to year two. Now, year two's got a lot going on. He starts year two with a balance that was from left over from the end of year one, $4,000. First thing that happens is he earns interest on that $4,000 balance for 1 year at 8%. So there's your formula to calculate it. It looks familiar. It's principal times rate times time. So for year two, his initial balance of $4,000 earns him $320 in interest. Now, here's the cool part. At the end of year two, he makes his second payment of $4,000. So as we end year two, his new balance reflects the initial $4,000, the interest added in, and his second payment of $4,000. So at the end of year two, Bill's annuity is worth the sum of those three values, or $8,320. We're ready to open up year three. Year three begins, and Bill's going to get a year's worth of interest on that balance that came over from the end of year two. So that $8,320 earns interest at a rate of 8% for 1 year, for year three. All right, so here comes our calculation for interest on the beginning balance of 8320. So it's 8320 at 0.08 for 1 year, the third year, and you already know what's going to happen. At the end of year three, Bill makes his third and final yearly payment of $4,000. All right, so again, if we're looking at his balance at the end of year three, which is what we were asked to calculate in this problem, how much is it worth at the end of that third year? Well, it's going to be the 8320 plus the 665.60 interest earned for that year, plus his third and final installment at $4,000. So there you see the sum of the three values getting ready to be added, 8320, 665.60, and 4,000. At the end of the third year, Bill's annuity has a value of $12,985.60. This is a regular ordinary annuity. The installment payments are made at the end of the year or at the end of the period. As we saw at the very first year, he really went a whole year where he didn't earn interest because his first payment was made at the end of the first year. So here's just a little summary for you. At the end of year three, that was the value of his 3-year annuity. So over the 3 years, he would have invested $12,000, $4,000 each year for 3 years. All right, and he earned at the end a total of $12,985.60. So we could find his interest. It's just the difference between $12,000 and that $12,985.60 number. Okay, we will refer to the $12,985.60 as the future value of the annuity. It would be the worth of that annuity at the end of its period of 3 terms or 3 years. Now that's kind of fun. I don't know if I'd want to do it for 30 years. I don't think I'd want to do it if we compounded monthly instead of once a year like we just did in the last problem. So while I wanted to show it to you in one shot, I don't think we're going to stay at that level. I think we need a formula. So here is our formula for ordinary annuity. You notice up there in red, this formula is applicable when you read the problem and see the notion of ordinary annuity. All right, values for us to look at. Future value, what's it worth in the future? That will be at the end of the last period. The payment is the payment amount, how much each of the periods that we're going to roll, might be years, might be quarters. Now we're going to play a little differently with N here. N is the number of compounding periods, and it's going to reflect the number of times that you compound per year, and it's also going to reflect the number of years. All right, so it's the number of years times the number of compounding periods in a year. So it's a little different than what we saw previously. The I for interest rate is the interest rate per period. And again, if we're going to compound quarterly, we'll wind up taking our interest rate yearly and cut it by 4. Okay, so watch out. You'll see these as we go into the examples. Formula is a little clunky, a lot of grouping. You can see it already. So groups are going to be important to us as we process. Here's an example. All right, Biff's got an ordinary annuity, 5 years, $3,000 every 6 months. So it's a semi-annual, and he's compounding at 6% compounded semi-annually. There's your formula. Let's find some values to roll. We'll be calculating the value for future value. All right, that's our unknown. So as we look at what we do know, we have a payment amount of $3,000, and we're going to make it every 6 months. The number of periods is 5 times 2. 5 as in 5 years, 2 as in twice a year. So there'll be 10 compounding periods over this annuity. And in fact, there'll be 10 payments of $3,000 over this annuity as well. The interest rate for each compounding period, since it's twice a year, is the yearly rate cut by 2, or 3%. So you can see the values getting substituted into the formula. Again, watch out for groupings. It's a lot to calculate. Your calculator's got no problem doing it in one shot, but if you want to break it down in smaller increments, that's fine as well. But remember, we're not rounding until the bitter end. Okay? So that's nice. We're just having a good old time. And what I think we should do is just go for the gusto. So in a minute, we'll look at keystrokes for those of you who didn't get to the 34,391 kind of number. If you did, props to you. You've done the problem correctly. And you know that at the end of the 5-year span, he's invested $3,000 every 6 months. And the worth of his annuity is $34,391. Let's make it 64 cents, if you will. So a little different on N than what we did previously. It involves what we had previously as N, which was the 2 in this context for semi-annually, but it also involves the years. If it looks like that was where you saw the power in previous work, that's exactly where it was. It was the number of compounding periods times the number of years. Okay. So at the end of 5 years, that's the value of his annuity, and we would have solved our problem. If the calculator is causing you stress and you want to look at keystroke entry, I decided that I would go ahead and show you what we could do. Important things. You've got to group that whole second expression. So you've got nested parentheses. I probably should have used different colors here on the different parentheses. It would have made it easier to see. You've got one set of parentheses around 1.03 to the 10th. You've got another set of parentheses that house the entire numerator, and your outsidemost set of parentheses houses the entire value before the multiplication by 3,000. And if you do that successfully, you should get the value that we just had on our last screen. That, my friends, ends video 1. We'll be back to take a look at video 2 and extend our look at annuities. See you soon.